Today's lesson, section 8.3a, will be talking about polar form of complex numbers and De Moivre's theorem. Now, De Moivre's theorem will be on later sections, so we'll mainly focus on the complex numbers part. So a complex number, or complex numbers, have two components, a real part and an imaginary part. So general form for a complex number is z equals a plus bi. So as you can see, a is the real part, so a real number, and bi, because b is attached to a value of I, which is imaginary, would be the imaginary part. Okay? So when graphing a complex number, the x-axis is the real axis, so we say that it's the real, and then the y-axis is the imaginary part. So if I want to graph the values of, or z equals 1 plus 1i, then I would go over 1 on the x and 1 up the y to get the point of 1 plus 1i. Okay? So it's kind of like an ordered pair in the same sense, but written differently. Also, a modulus of a complex number is considered to be either the absolute value of it, because you take the absolute value z, or, kind of like when we were doing vectors, it's also the magnitude, okay, or that distance between the first point or the origin to your complex number. So to find that modulus of a complex number, we would take the square root of a squared plus b squared. Okay, so exactly like a magnitude. Example 1 says they want us to graph and find the modulus of the following complex numbers. So here we want to graph negative 7 plus 2i, so I go over negative 7, okay, and then I go up 2, and then that would be my point, and labeling it. For letter B, graphing would be 4 on the real and 9 on the imaginary. And there you go. Now finding the modulus. Now notice when we take these, and even in the formula, we do not plug in the I value. That's one thing I've seen in the past, that students plug in the I with that 2, and then they get some other random number, which is not correct. Because then you think I squared, which is perfectly fine, but then you change that to negative 1, which is subtract. So instead of getting square root of 53 like you should for your modulus, you would get square root of 45, which is not correct. Okay. Same thing for letter B. I square both 4 and 9 to get 16 and 81. That would get me the square root of 97. Okay? Now, next example, we want to be able to perform the following operations for the given complex numbers. Now, one thing to remember, and you might want to remember this in your notes, remember I represents the square root of negative 1. But if I take I squared, then that would be like squaring the square root of negative 1, which leaves me with negative 1. And then I cubed is like negative I, because it's like taking I times negative 1, which gets you negative I. And then I to the fourth is 1, because it's like negative 1 squared. So the one that you really want to remember is I squared is negative 1, and just know that I is equal to the square root of negative 1. The other two won't really show up very often when we're doing this stuff, but it's just a nice to know kind of thing. So going back to letter A, I want to put like terms together. So negative 3 and 4 add together gets you a positive 1. And then 2i and negative 5i go together to get you negative 3. So you get 1 minus 3i. Same thing with letter B, except I want to distribute my negative through. Okay, so then negative 6 plus a negative 12 and a 10i plus I will get me negative 18 plus 11i. Okay? Now, letter C, we need to be able to multiply. So here you have a binomial times a binomial. So I'd multiply, or using FOIL. So take the 3 times 8, gets you 24. 3 times negative 2i would be negative 6i. 4i times 8 would be positive 32i. And then 4i times negative 2i would be negative 8i squared. So now you have two like terms in the middle. And remember that because I squared is negative 1, what I like to do usually is to cross out the I squared and change the sign of the variable or the value that is in front of your I squared. So now it becomes positive 8, because it's like saying negative 8 times negative 1 would get you a positive 8. Okay? So 24 plus 8 gets you 32, and then negative 6i plus 32i gets you a positive 26i. Or sorry, negative 26i. Okay? Now the next thing is to be able to put these in polar form. So a complex number, z equals a plus bi, has a polar form, or in trigonometric form, so we're using cosine and sine, is equal to z equals r, so the radius, times cosine theta plus I sine theta. Okay, another way of saying this form, and we'll say it for shorthand, is cis form. Okay, because you get the CIS. Okay, so cis form is another way of saying this as well, that we'll use shorthand wise, like in for our tests and stuff like that. Okay, now the r is the same thing as the modulus, so that's square root of a squared plus b squared, and theta comes from tangent of theta equals b over a. So how we get that is based on those values from your complex number. So the number r is the modulus, and z of z, and then theta is an argument. That's one word that will be in the book sometimes, or on an assignment, or a test or quiz or something. It just means the theta, the angle. Okay? It's just a different word. So don't worry that it doesn't mean something different. It's just representing your theta. Example 3 says that they want us to put each complex number in polar form. So to do that, it would be helpful to map where these are on the graph. Now you don't have to do a really special one, just generally. So negative 2 would be down on the imaginary because your real value is 0. So then I would go all the way over to get to that point. Remember, kind of like this is your initial side. So then I always decide what my angles are based on that. Okay. So now when I find my modulus, so then my real part's 0 plus negative 2 squared. So I get 0 plus 4, which is square root of 4, which is 2. Okay, so now you want to be able to find your angle measurement. So tangent of theta is going to be equal to b over a, which is negative 2 over 0. Now look at this, because remember this means undefined, because if you plug this into your calculator as it is for your inverse tangent, you do not get an angle. Okay? So, go back to your picture to help you out. So what angle would that land on? So remember, this is 90 up here. Over here is 180. Okay? So then you get 270. Now most of the stuff they put in radians. So remember, 90 is pi over 2, 80 is pi, or 180 is pi, and then 270 would be 3 pi over 2. So that's what our angle would equal. So now all I have to do is plug in r and theta. So when plugging this in, I would get z equals radius 2 times cosine of 3 pi over 2 plus I sine of 3 pi over 2. And then that would be my polar form. And you could also multiply it out, but there's really no need. Okay? So let's try letter B. Here we have an A value this time. So same thing, I want to kind of judge where it's at. So going down -2 again for my I, and then going over however much -2 square root of 3 is, that would make my angle go all the way into the third quadrant. Okay, so it should be in there when I do tangent. So now I want to find my modulus. So -2 square root of 3 squared plus -2 squared. So that gets me 4 times 3 plus 4. And then that gets me 12 plus 4, which is square root of 16, which is 4. So my radius is 4, and now I want to do my tangent. So B is -2 over -2 square root of 3. The -2's cancel out, so it leaves me with 1 over square root of 3. Now thinking about your radicals, or your ratios again, for sine and cosine, what values get you 1 over square root of 3. You're in the third quadrant, so this is going to be, these are typically going to be nice numbers. One of the ratios that we got was 1 over square root of 3 all the time, or square root of 3 over 3, whichever way you wrote it. So now here, if I look in the first quadrant, that ratio would be pi over 6, because then you would get the value of square root of 3 over 2, comma 1/2. So when you rewrote tangent for that one, you do your sine over your cosine, and then you multiply it by the reciprocal. 2's cancel out, leaves you with 1 over square root of 3. But since you're in the third quadrant, the ratio that gets you that is the one opposite of pi over 6, which is if you added pi over, so it got you 7 pi over 6. So now I just need to plug in my radius of r, or 4, and my theta. So 4 times cosine of 7 pi over 6 plus I sine of 7 pi over 6. And that would be my polar form of -2 square root of 3 minus 2i. Okay? Have fun.